Alright, so here is your key to your review. First thing we're going to do, we'll find the area of a parallelogram. So the first thing we always do is write down our formula. Area of a parallelogram is base times height. The base is 10. The height is not 7, it is 5, because height is always perpendicular. So that is going to be 10 times 5, which means the area of the parallelogram is 50 feet squared. Then I'm going to find the height of the rectangle given that area. So the area of the rectangle is equal to base times height. I know the area of the rectangle, it's 10x squared. I know the base, which is 2x, and the height is what I'm looking for. So to get the height by itself, I'm going to divide both sides by 2x. These cancel out, that's why I did it. So the height is equal to 10 divided by 2 is 5, x squared divided by x is x, and my units are feet. So now I am looking for the exact area of the segment. So in order to find the area of the segment, remember that is the area of the sector minus the area of the triangle. Okay, so we're going to start with the area of the sector. To find the area of the sector, one of the things I need is the area of the circle. Area of the circle, pi r squared, the radius is 4, so it's going to be 16 pi. Then to find the area of the sector, I have to do the measure of the arc, which is 120, over 360, and that's equal to the area that I'm looking for over the whole area of the circle, which is 16 pi. Okay, so I can knock out those zeros, and then I'm going to multiply 12 times 16 pi and divide that by 36. Then I'm going to reduce and go ahead and do the 12. We'll go into 12 once and the 36 3 times. It's going to give me 16 pi over 3. And that's the best I can do there. So the area of the sector is 16 pi over 3. I'm not done because I've got to find the area of the triangle so that I can then have the area of the segment. So for the triangle, I know to find the area of a triangle, it is 1/2 base times height. All right, well, I don't know the base or the height of the triangle. I mean, I could use the 4 as the base, but I don't know that that would be the best thing to do in this situation. So I'm going to redraw this triangle, and I know that this is 120, and this is 4, and this is 4, because it's the radius. It's basically this. I just took it out, and I flipped it around because I want to use this as the base. So I think it makes more sense when the base is actually on the bottom. So I don't know what the length of the base is, or the height, but I do know that this is 120, and if I draw in the height, it's going to break this into two little 30, 60, 90 triangles. So if this was 120, this is 60, and this is 30. Which means that if this length right here is 4, then this length, then the height is going to be the short leg, so it's actually going to be 2, and this is 2 square root of 3. Which means the whole base of the triangle is going to be 4 square root of 3. So when I go substitute all that back in, it's going to give me 1/2 times the base, which is 4 square root of 3, times the height, which is 2. So 1/2 times 2 is just 1. So that gives me that the area of the triangle is 4 square root of 3. So I have those two pieces. Then I just have to put them together, and I know what to do. I'm subtracting, so it's sector. So my total area of the segment is going to be the area of the sector, which is 16 pi over 3, minus the area of the triangle, which is 4 square root of 3. I would combine my like terms if I could. I can't, so I put my parentheses around it, and it's miles squared. So then I'm finding the exact area of the sector. So area of a sector is the measure of the arc over 360, and that's equal to the area of the sector over pi r squared. So the radius is 6. That is a 6 and not a 5, right? It's hard to tell. I'm going with 6. All right, so we'll say that's a 6. I'm pretty sure that's what that is. So pi r squared, that's going to give me a 36 pi there. The measure of the arc is 70, so it's going to give me 70 over 360. And that's equal to the area of the sector over 36 pi. So the zeros cancel out. That's going to give me 7 times 36 pi over 36. The 36's cancel out, and the area of the sector is equal to 7 pi centimeters squared. All right. So I'm going to find the area of the parallelogram with this information. So here's my parallelogram. The base is 3x plus 5. The height is 7x minus 1. Area of the parallelogram is base times height. So that is going to be 3x plus 5 times 7x minus 1. So then I FOIL or do box or do whatever is what makes sense to you. So when I do that, it's going to give me 21x squared minus 3x plus 35x minus 5, which means that gives me 21x squared plus 32x minus 5, parentheses, feet squared, and that is equal to the area of the parallelogram. Kind of ran out of room. All right, now we're going to find the area of this parallelogram. Formula is still base times height, right? So I know the base, it's 10. This is the height. I don't know what that is, but if I move that over here, then this is a 30, 60, 90 triangle. If this is 6, then this will be 3, so the height is 3 square root of 3. It's going to give me 10 times 3 square root of 3, so the area of the parallelogram is equal to 30 square root of 3 centimeters squared. All right, so now I'm going to find the area of the triangle. So my triangle, base is x plus 1, height is 8x, area of a triangle, 1/2 base times height. So it's going to give me 1/2 times x plus 1 times 8x. I can multiply in any order, so I'm going to take half of the 8x, so that gives me x plus 1 times 4x, which will then give me 4x squared plus 4x, feet squared, and that's the area of my triangle. All right, I'm going to find the base of the triangle, in which the area is 81 inches squared, so I know that the area of the triangle is 1/2 base times height. Area is 81. That's equal to 1/2 the base I don't know times the height, which is 9. So I could multiply the 1/2 times the 9, but it's an odd number, so that's just going to give me a fraction anyway. I can go ahead and multiply both sides by 2 and get that 81 times 2 is 162, and that's equal to 9 times b, which means then that the base is equal to 162 divided by 9. So I know 9 is divisible by 3. 162, if I add those digits, these add up and give me 9. So since they are both divisible by 3, but when you add them up, if it's divisible by 9, whatever you get, then this number is divisible by 9. So 9 goes into 16 once with 7 left over, so that's 72. 9 goes into 72 18 times. So 18 inches would be the base. Or you can reduce by 3 and then reduce by 3 again if you don't notice that. Okay, finding the area of the rhombus. All right, so area of the rhombus is equal to 1/2 d1 times d2. So I know one of the diagonals, d1 is 14, or it could be d2, it doesn't really matter, but I need d2 to be able to get the other diagonal. So I'm going to draw in d2. When I do that, the diagonals bisect each other, so this is now 7 and 7. And I can call this x and x. And when I do that, d2 is actually 2 times whatever x is. So when I find x, I got to make sure that I double it to use the actual diagonal. Got to know some things about rhombi, right? So rhombus, the diagonals are perpendicular. So you've got a little right triangle, and you can do Pythagorean theorem here. So this is going to be 7 squared plus x squared equals 25 squared. So this is 49 plus x squared equals 25 squared, which is 625. So x squared equals 576, which means x is 24. This is actually a Pythagorean triple, 7, 24, 25. So since x is 24, d2 is actually 48. Gotta make sure I use the right thing. So when I go back over here and substitute this in, I'm going to get 1/2 times 14 times 48. So I can take half of 48 and get 24, but then I have two two-digit numbers. I think I'd rather multiply 7 times 48. So 7 times 40 is 280. 7 times 8 is 56. So when I add those together, it's going to give me 336. Yeah. Okay, so the area of the rhombus is 336 inches squared. That would take you a whole lot longer than what I just did if you don't know your multiplication facts and you don't know your perfect squares. Okay, those are things that help you along the way. All right, next one. I'm going to find the area of the rhombus. It gives me both of the diagonals, so I know that the area of the rhombus is equal to 1/2 d1 d2. And I don't really have a whole lot of room for any of that, so I guess I'll do it here. 1/2 times d1, which is x plus 4, times d2, which is 2x minus 4. So I've got some options here. I can go ahead and multiply the binomials and then distribute my 1/2, or I could distribute that first. I definitely don't want to distribute it here, though, because I would still have a fraction in there. But if I take this 1/2 and distribute it to this one, then I can get rid of my fraction. So I'm going to leave the first one alone, x plus 4. But the second one, I'm going to distribute the 1/2, so that becomes x minus 2. So then I FOIL, box, whatever, and it's going to give me x squared minus 2x plus 4x minus 8, which gives me x squared plus 2x minus 8, parentheses, meters squared. That's the area of the rhombus. All good? All right. So now I'm going to find D2 in the rhombus here. So I know that the area is I know that the area of the rhombus is equal to 1/2 d1 d2. So when I substitute all this in, this is going to give me the area, which is 3x squared plus 6x is equal to 1/2 times d1, which is x plus 2, times d2, which is what I'm looking for. I'd like to get rid of that 1/2, so I'm going to go ahead and multiply both sides by 2, which means I got to make sure that I distribute it over here. So this is going to give me 6x squared plus 12x, and that's equal to x plus 2 times d2. So then I divide, and d2 is equal to 6x squared plus 12x, divided by x plus 2. I got two options here. I can do polynomial long division, or I can factor out the GCF. So I'll show you both. If we factor out the GCF in the numerator, that's going to be 6x. So that leaves me with x plus 2. And in the denominator, x plus 2. And those cancel out. Or if you're thinking you wouldn't think to factor out the GCF, then you can do x plus 2 divided into 6x squared plus 12x. X goes into 6x squared 6x times. So 6x times x is 6x squared. 6x times 2 is 12x. And when you subtract all that, you get 0. So there's your answer. You get it either way. That d2 is equal to 6x meters. Okay. Both of those situations review from Algebra 1. All right, so now we're going to find the exact arc length. So our arc length formula is that you have the measure of the arc over 360. That's equal to the length over 2 pi r. So the radius is 18. So 2 pi r times 18 is going to give me 36 pi. I'm looking for, well, I didn't tell you which arc, but I guess this is really the only one that I can, we need to do this one or the other one, but AB is what we're looking for here. So the measure is 140 over 360, and that's equal to the length over 36 pi. So the zeros cancel out. I'm going to cross multiply and get 14 times 36 pi. Remember, I could have reduced that, but if I don't, it actually helps me out. Divided by 36, because then those cancel out. And I'm just left with the arc length equals 14 pi meters. 16. Actually, let me go back up. Oh, there's some on this other side. I'll do this. And then I think it stops being 2 columns. Yeah. All right, so I'll go back up and do 13. I'm looking for D1 of the kite. So I know that the area of the kite is equal to 1/2 D1 D2, just like it is for a rhombus. So the area is 126. That's equal to 1/2 of D1 that I'm looking for, times D2, which is 12. So I can go ahead and take half of 12, so I get 126 is equal to 6 times D1. So D1 is equal to 126 over 6. Well, they're both even, so that's going to give me 63 over 3. And then that reduces to 21. So that's equal to D1, and that's feet on there. All right, so the grid is made up of 1 by 1 squares. I'm going to find the area of the 3 shapes A, B, and C. All right, so the grid, these are 1 by 1 squares, so each one of these is 1 unit, way down here. So the side length of the square is not 1 unit. It's 1 diagonal, but it's not 1 unit. And if these are squares, if this is 1, this is 1, so this is 1 square root of 2, or just square root of 2. And they're all just 1 diagonal. So the area of a square, which I don't think we even really talked about, the area of a square is side squared, but a square is a rectangle, and a rectangle is a parallelogram, so you can use base times height. That's basically where you get the side squared from. So either way, which is the same as base times height, it's just that base and height are the same thing. So it's the square root of 2 squared. So the area for shape A is 2 units squared, because the square root of 2 squared is 2. So then when I go to do B, area of shape of B, that is a triangle, so that is 1/2 base times height. Well, this is I can do it a couple of ways, actually. This right here, that length is 1, 2, 3, 4 units, because they were all 1. So the base is 4 times the height, which is just 2 units. So the area of shape B is 4 units squared. C is a trapezoid. So the area of shape C is 1/2 base 1 plus base 2 times the height. So the height is the square root of 2. This base is the square root of 2. And this base is 2 square root of 2. This side length is 2, but we don't care because you need the bases and the height. So this is equal to 1/2 square root of 2 plus 2 square root of 2 times the height, which is square root of 2. So I'm going to combine these here before I do anything else. It's going to be 1/2. So square root of 2 plus 2 square root of 2 would give me 3 square roots of 2. They're things. You have 2 of them, you add 1 more, now you have 3 times the square root of 2. So before I actually multiply this 1/2 in, let's think about what we have here. This is 1/2 times 3 times the square root of 2 times the square root of 2 is 2. So 1/2 times 2 is just 1. So the area of shape C is 3 units squared. All right, so I'm going to find the circumference and the area. So circumference is 2 pi r. Area is pi r squared. This is going to give me 2 times pi times the radius, which is 3x. I don't have enough information to actually figure out what x is, so my circumference is just 6x pi inches. Area is going to be pi times 3x squared. I got to square the whole thing. So this is going to give me the area of the circle is 9x squared pi inches squared. Okie dokie. 17. 17, we're looking for the area of the regular polygon. One second. My board's not reacting. Okay. Area of a regular polygon. So the area of the polygon is equal to 1/2 apothem times perimeter. So in this case, they actually gave me the apothem, right? But I then have to find the side length so I can find the perimeter. Perimeter is n times s. N here is 6. So it's 6 times whatever the side length is, and I have to go find that. So come over here and I start the same way every time. Draw in 2 radii. Find my central angle. That's 360 divided by 6. So that's 60 degrees. This is my apothem. These are congruent because it's an isosceles triangle, and then these pieces are congruent because the height bisects it. So then I'm going to redraw my triangle so I can actually look at what I have here. This whole big angle is 60. This is 14 inches. I know those are congruent. Those are congruent. And then, since the whole thing is 60, this is 30, and this is 30. So I have little 30, 60, 90 triangles, which means that this is s, 2s, and s squared root of 3. So since 14 equals s squared root of 3, I have to divide by the square root of 3 to get my side length. So 14 divided by the square root of 3, I then have to rationalize. So my side length is equal to, or my s, I'm sorry, is equal to 14 square root of 3 over 3. That's this right here. Now, I don't really care about the radius, but the s that I just found is not this s. This stands for side length, that stands for short leg. So that's another, remember, you draw out the whole triangle, because what you really need is this whole thing. So if this is 14 square root of 3 over 3, this is 14 square root of 3 over 3, which means the whole thing is 28 square root of 3 over 3. So that's my side length, 28 square root of 3 over 3. Multiplying something that is a fraction by something that is not, and put that over 1. I can actually reduce before I do anything else. like that too. So I'm really just doing 2 times 28. And your perimeter is, let's see, 40, 56, oops, sorry, not that. I don't know what I'm writing there. 2 times 20 is 40. 2 times 8 is 16. That's the 56. Square root of 3. There's your perimeter. Let's come back over. Substitute your stuff in. We got 1/2 times the apothem, which is 14, times the perimeter, which is 56 square root of 3. 1/2 of 14 is 7. 7 times 56 square root of 3. So 7 times 50 is 350. 7 times 6 is 42. So that's going to give me 392 square root of 3 inches squared. Alrighty. So now I'm going to find the area of this regular polygon. So again, I know that the area of a polygon is equal to 1/2 apothem times perimeter. They did not give me the apothem. They don't really ever give me the perimeter. Perimeter is n times s. N here is 6. S is 10. So your perimeter is 60. Draw my 2 radii in. Okay, this is a hexagon, so this is 60. I need my apothem. And then I separate and redraw my triangle. Okay, this whole, that doesn't look very good. That's fine. This whole thing is 10. This is my apothem. This whole thing is 60. That means that this is 30. This is 30. This is 5. This is 5. So this is 5 square root of 3. Substitute it all back in. 1/2 times the apothem, which is 5 square root of 3, times the perimeter, which is 60. So half of 60 is 30 times 5. You get the area of the polygon is 150 square root of 3 inches squared. So number 19 is another, find the area of the regular polygon, give you the radius that's 10. It ends up being the exact same problem because in a hexagon, you get equilateral triangles, and so the radius is the same as the side length, so you end up getting the exact same stuff. So I'm going to change this problem a little bit so that we can do another one and do it a little bit differently. If you already wrote stuff in the blank or whatever, it's fine. You can do it separately. If you may not have realized it was the exact same thing until you were done. But I apparently didn't put one on here that when it's not a hexagon or a triangle. So we're going to pretend like this is we're still going to use the radius of 10. But we'll do an octagon where the radius is equal to 10. Okay? So it's okay if you can't draw an octagon. Mine's going to look pretty sad too. Yours may be beautiful, I don't know. But an octagon, if you kind of start off this way, it doesn't have to even be decent for you to be able to do the problem. Just get 8 sides. Even if you can't get the 8 sides, it doesn't matter. Like, that's really bad. But it has 8 sides, and it's good enough for what we do. We just pretend like it's regular, right? And it does have 8 sides, right? Yeah. So when I draw this in, okay, I know that my area of my polygon is equal to 1/2 apothem times perimeter. So we're still going to use the radius of 10, but since it is an octagon and not a hexagon, then I've got to treat it differently. And it would probably be to your benefit, if you're watching this video, to pause the video and try and work it out on your own, and then watch me do it. So this is 10 and 10. So I'm going to take, and this is my apothem. Then I need to find this angle here, which is going to be 360 divided by 8. Okay, so 360 divided by 8, half of 360 is 180. Half of 180 is 90, so that's dividing by 4. Then divide by 8. You do it again, and you get 45. Okay, so your central angle is 45 degrees. So I'm going to redraw my triangle but bigger. So this right here, the whole thing is 45 degrees. This is 10, this is 10. This is my apothem, and I know that these are congruent here. So this does not give me special right triangles, even though that is 45, because I have to cut that in half. And so it's 45 over 2, but I'm going to have to end up using a calculator anyway, so 22.5 is fine. 22.5, 22.5, because what I'm going to have to do here is trig. I'm going to call this x so that I have something to call it. And this is my angle. So this is the opposite, this is the hypotenuse, and this is the adjacent. Okay. Because I have to find the apothem, and in order for me to find the perimeter, it's n times s. I know the number of sides is 8. The side length, though, however, I don't know, so I've got to find both of them. And so when I do this to find we'll find the side length first, since we have to do that. That's my opposite, and I know the hypotenuse, so I'm using what? Sine. Good. So I'm going to take the sine of 22.5, and that's equal to the opposite, which is x, over the hypotenuse, which is 10. So x is equal to 10 times the sine of 22.5. So then in your calculator, I'm going to do, you want to check that you're in degree mode. 10 times the sine of 22.5. Okay, so that's equal to x. But x is not actually what I'm substituting in. Because remember, this is why we redraw the whole triangle. What I need is s, or the side length, so I need to double that. I'm going to multiply that by 2. And since that represents my side length, I'm going to store it in alpha s. That's really hard to see on this board. I think that's it. I'm going to store it in s since that's what I'm calling it. Okay, so your x was like 3.82 something, but the whole thing, which is s, I already forgot, is like 7 point something. But it's stored, so it's fine. So I'm going to come back over here, and I'm actually going to substitute in s. I'm going to circle it, and I'm going to find my perimeter. Let the calculator do that for me. This is going to be 8 times alpha s. And since that represents the perimeter, I'm going to store it in P for perimeter. So I'm going to store it alpha P. I think that's that right there. And so that's my perimeter. It's 6.229. I'm sorry, 61.229. 61.229 ... Okay, but that is a stored number. I have my perimeter. I need to find the apothem, which is also something I'm going to have to store. That's the adjacent side, so I've got to do trig again. So I'm going to use, I could use the x, except I didn't store it, and you won't want to use a number like that unless you have to. So use what they gave you. I'm going to use adjacent and hypotenuse, which is cosine. So the cosine of 22.5 is equal to a over 10. So a is equal to 10 times the cosine 22.5. Go to my calculator, and it's going to give me 10 times the cosine of 22.5, and that's my apothem, so I want to store it in A for apothem. So I've got my apothem is equal to 9.2 something, something, something. So when I go back up here to substitute this in, this is going to be 1/2 times the apothem, and I'm going to circle it because I'm using what's in my calculator. It's stored, and my perimeter is stored also. So that when I go back to my calculator, if I stored everything like I was supposed to, I'm just going to take half, which I can just use as 0.5, times A times P. 1/2 apothem times perimeter. Bam, there's my answer, 282.843. 282.843. We'll make those inches squared. That is the area of the octagon, or the polygon, however you want to say it. Got to be able to store it, know to use your trig, and not just use special right triangles for this stuff. Okay? We good? All right. Now let's look at this area, this regular polygon. It is a triangle, so I could find the area of the triangle, but remember, if you're given stuff that lends itself to regular polygons, I would use a regular polygon. Perimeter is equal to n times s. What they give me is the apothem. So I draw in the two radii. This angle is 360 divided by 3, which is 120. I redraw this triangle out here so I can find what I need. Because I have the apothem, it's 3. This whole thing is 120. I know that these two are congruent, and these two are congruent. So this is 60 and 60. So if across, this is 30, so this is s. This would be 2s, but I don't really care about the radius. And then this is the long leg, so this is s squared root of 3, or 3 squared root of 3. Which means the whole side length is 6 squared root of 3. So n is 3. Side length is 6 square root of 3. So my perimeter, 18 square root of 3. And apothem they gave me, so I can come back over here. And this is 1/2 times the apothem, which is 3, times the perimeter, which is 18 square root of 3. Half of 18 is 9. 9 times 3 is 27. And there's the area of the polygon. The next one, since this is 5, when I draw in this triangle, that means this is 5, so this whole thing is 10. So it's that same question once again. And I'm not going to do it again because you get the same thing that you would have gotten in number 18. I wasn't very creative with my numbers here. Just gave you the same thing over and over again. Okay, so find the area of the shaded region on 22. And there's like this space here that doesn't really belong there. And I'm not sure that you can even tell what's shaded. So this is the intention of the shaded area. You got a couple options. You can cut it up into pieces and find the pieces and add them together, or you can find the whole thing and subtract out the middle. And my numbers, where the heck does 3 inches go? That doesn't even make any sense. I think that you know what? I just realized what happened. That 3 inches that's right there was actually covering up probably the measurement on 21, so it wasn't the same question over and over again. Because 3 inches doesn't even make any sense here. I'm thinking this actually goes here, and when I move things around, sometimes things jump around, I don't catch it. This makes no sense there. It doesn't even make any sense. I think it belonged somewhere else, and sometimes I don't notice that it jumped. Because a random 3 inches in there makes absolutely no sense at all. So we're just going to ignore that, and this is how this problem would go. I think that my plan here, I mean, you can have, as long as you have a plan, I don't care. If it's adding 3 rectangles together, fine. If it's taking a big rectangle and subtracting out the little rectangle, that's fine too. If you don't want to do little shapes and draw them, you can say rectangle 1 minus rectangle 2. I don't care. You can say big rectangle minus little rectangle, whatever works for you, right? So I'm going to find the area of the first rectangle, so area of the first one, which is base times height. All right, so base times height of the big rectangle. Base is 16, height is 12. Okay, so to multiply those two together, 10 times 16 is 160. 2 times 16 is 32. Goodness. And so that's going to give me 192 for the first area. Then for the second rectangle, it's just 4 and 12. So the area of the second one is still base times height. So it's going to give me 4 times 12, which is 48. And then I just subtract them. 192 minus 48. So 192 minus 40 is 152. And then 152 minus 8 would be 144. So the area is equal to 144 feet squared. Alrighty, so then on this one, I need to find the area of the composite figure. So I am going to find the area of the triangle, and then I'm going to add to it half the area of the circle. So yes, you can find the area of a semicircle, but really it's better so you're not manipulating formulas and confusing yourself to find the area of the whole thing and then take half of it. All right, so area of a triangle, I know that we can do that with 1/2 base times height. It's a right triangle, so to use the legs as the base and height is usually the easiest. This is 3. I don't know this, but this is a right triangle, so I could find this. You can find it with Pythagorean theorem, or it is a 3, 4, 5 triangle, which means the whole side length here is 4. So it's going to give me 1/2 times the base, which is 3, times the height, which is 4. So the area of the triangle is 6. Then for the circle, area of the circle is equal to pi r squared. So pi times the radius here is 2. 2 squared is 4. So this is going to give me, so the area of the circle is 4 pi, but I only want half of it. And half of 4 pi is 2 pi. So half the area of the circle is 2 pi. So I found the area of the triangle. I found half the area of the circle. All I have to do is add them together now, and my final area is going to be the triangle, which is 6 plus 2 pi. That does not combine to be 8 pi because they're not like terms. That's the best I can do, and that's kilometers squared. And whether it's 6 plus 2 pi or 2 pi plus 6, it does not matter either way. Okay? All right, 24. I'm going to find the area of the composite figure. All right, so I have this windmill-looking thing, and this shape right here gets repeated 4 times. So I really only have to find it once, and then I can multiply it by 4. That shape is a what? Trapezoid. So I'm going to do 4 times trapezoid plus 1, and this is 1 by 1, so that's 1 square. So I need to find the area of the trapezoid. The area of a trapezoid is equal to 1/2 base 1 plus base 2 times the height. So this is going to be 1/2 times base 1 to be 1 plus base 2, which is, what is it? 2 times the height, which is 3. All right, so 1 plus 2 is 3, so this is 1/2 times 3 times 3. So that's really 9 times 1/2, so the area of a trapezoid is 9/2. Then I need to find the area of the square. So area of a square is just side squared, and the side length of the square is 1, so it's 1 squared, which means the area of the square is 1. So to put it together, once I found those pieces, I need 4 of the trapezoids, which are 9/2, plus 1 of the squares. So 4 times 9/2, I can put that over 1. I can reduce that. So it's going to give me 18 plus 1, which is going to give me 19 inches squared for my final area. All right. So now on this one, we're going to find the area of the composite figure. So then I'm going to have it, my plan is that to have an area of a rectangle plus the area of a parallelogram plus half the area of a circle. All right, so start with the area of the rectangle. Area of the rectangle is equal to base times height. That is 15 times 9. Okay, so 9 times 10 is 90. 9 times 5 is 45. So 90 and 45 is going to be 135. Then I need to find the area of the parallelogram. So the area of the parallelogram, let's see what this tells me here. I didn't even read the rest of this. The length of AF, right here, is equal to the length of FG, right here, which means this is 9. the length of FC, this right here, is equal to ED, which is equal to FE, which is equal to CD, right? And then, did I miss one? FC, oh yeah, 15. Okay, so is that a square? Doesn't have right angles, so what is it? Because these are all four congruent. It's a rhombus, okay? So it is still a parallelogram, but it is a more specialized parallelogram, and it is a rhombus, which means I'm not going to use the base times height because I don't really have the information to find that. Instead, I'm using the area formula for a rhombus, which is equal to 1/2 d1 d2. So I have to find the diagonals. Well, I know that this part is 9, so what is this part right here? 9. So I can say d1 is 18. Does that this? The diagonals bisect each other. These two pieces are congruent, but they are not congruent to these two pieces. The diagonals are not congruent unless you have a rectangle. But what do we know about the diagonals of a rhombus? They're perpendicular. So I get little right triangles here. So I can find this length, right? And when I do that, this is a 3, 4, 5 triangle in disguise. You can do Pythagorean theorem, it doesn't matter, but you get 12. It's 9, 12, 15. But if you don't just know it, it's fine. You do Pythagorean theorem. You don't have to just know them. Mm-hmm. Yeah, that's where your 3, 5s, yeah. It's like in disguise there. So you can split it up. Let's see. Maybe I can do that like right here. So when you have a 9, 12, 15. So this really is 3 times 3, 3 times 5, 3 times 4. That first 3 doesn't really mean anything because this first 3 these could all be 4s. Like these all have to match each other, but then there's your 3, 4, 5 that's in disguise. It's just the multiple of it. It's just a bigger form of it. That's all that is. Just make sure that you're not assuming anything. You're not, like if it gets confusing and you don't know if that's really what you're recognizing, just do Pythagorean theorem and you're safer. But if you can start to recognize those, it does help a little bit. Okay, so this is 12. So this is 12, which means D2 is 24. Be careful not to just use half of it. So when I come back over here to substitute it in, this gives me 1/2 times 18 times 24. So I would prefer to make that 9 times 24, because I can do 9 times 20, which is 180, 9 times 4, which is 36. So it's going to give me the area of the rhombus is going to be 216. So then I have to find the area of the circle. I'm only going to need half of it, but I need to find the circle just as it is. That's pi r squared. So I know that this whole piece right here is 15. That's not the radius, that's the diameter. So the radius is going to be 15 over 2. Because I really don't think you want to be squaring 7.5 because you would never get it back out of that anyway. So this is equal to pi times 15 halves squared. Squaring fractions is easy because you're just multiplying it by itself. So 15 squared is 225. 2 squared is 4. So this gives me 225 pi over 4. That's the area of the circle. And I sort of, that's not my final answer, sorry. Sort of ran out of room to do the whole final answer, but I'll do that up there. So to put all that together, I'm supposed to do rectangle plus rhombus plus half the circle. So the rectangle is 135 plus the rhombus, which is 216, plus half of the area of the circle, which is 225 pi over 4. There's 3 terms, but only 2 of them can I combine. I can combine the 135 and the 216. So if I do it a little bit at a time, 216 plus 100 is 316. Then I add my 30. That's going to give me 346. And then I can add 5 more to 346. It's going to give me 351. Okay. So this gives me 351 plus, and then multiplying that by 1/2 is easy. You just multiply straight across. 225 pi over 8. That's my answer, I guess, units squared. That's the area. All right, so this is the one where I sent out a reminder about the side length. The side length right here is 12. So I have to have a plan for the shaded region. And so my plan is to take the rectangle minus the hexagon. But I don't really have any information about the rectangle. But if I need to kind of understand what's happening here, the whole bottom or the base of the rectangle, it's the same distance here, and that right there is just the radius twice. Okay, so this right here is the same as 2 times whatever the radius is, which we'll look at that in just a minute. It doesn't technically have a diameter even though it's 2 times the radius. So when I go to draw in my triangle, like I do for all of these, and my apothem here, notice that the apothem right here is this right here also. So this is the apothem and this is the apothem. So this whole side length is just 2 times whatever the apothem is. And I'll have to find all that stuff. I usually don't need to find the radius, but I can and it's no big deal. This is a hexagon, so this whole angle here is 60. And then I separate and redraw my triangle out here. Here is my triangle, my apothem. This whole thing is 12. This whole thing is 60. So that means this angle is 30 and this is 30. So if this whole thing is 12, this is 6, this is 6. These are actually 12 as well. Because it is a hexagon, I get an equilateral triangle. So the radius is 12, which means I knew that this was 12, this was 12. So this whole thing is 2 times 12, which is 24. This whole thing is 24. That's where I messed up before. All right, so that's 24. And then I need to find my apothem. So if this is 30, this is my short leg, this is 6 square root of 3. So that means this is 6 square root of 3, this is 6 square root of 3, so this is 12 square root of 3. So I have the pieces I need for my rectangle. Area of the rectangle is base times height. So the base of the rectangle is 24 times 12 square root of 3, which is the height. So instead of worrying about multiplying 24 times 12, think about what you have when you, we didn't multiply them together, but you can split it up a little bit. This is the same as 2 times 12 times 12 square root of 3, because 2 times 12 is 24. Well, 12 times 12 is 144. Way easier to double 144 than it is to try and multiply that stuff. So 144 times 2 is 288. So the area of the rectangle is 288 square root of 3. So there's my rectangle. So now I need to find the area of the polygon. So the area of the regular polygon is equal to 1/2 apothem times perimeter. So perimeter is n times s. So n is 6, and that's the number of sides. S is not this length, it's the side length of the hexagon itself, which was 12. 6 times 12, perimeter is 72. And then I already found the apothem is 6 square root of 3. So I substitute this in. I'm going to do 1/2 6 square root of 3 times the perimeter, which is 72. 3 square root of 3 times 72. 3 times 70 is 210. 3 times 2 is 6. So the area of the polygon is 216 square root of 3. So then when I put it all together, my plan is rectangle minus hexagon. So my total area, rectangle is 288 square root of 3 minus the polygon, which is 216 square root of 3. So a lot of times we can't actually combine these, but here we can, because they both have square roots of 3 on them. If I do a little bit at a time, 288 minus 200 gives me 88. 88 minus 10 gives me 78. 78 minus 6 gives me 72 square root of 3. And that is my final area, just units squared. Alrighty, next one isn't nearly as complicated. We know all of these little pieces are congruent, so if this is 8, this is 8, and so are all of these, gives me 16, and it's a square. Okay, So the whole big thing is a square. Each one of these little sections that's not shaded is a fourth of a circle, but it's a fourth, they're all the fourth of the same circle, right? So if you put 4 of them together, you get a whole circle. So your plan from the beginning can just be square minus circle. Okay? And it can be, so you can treat it as a square, you can treat it as a rectangle, doesn't matter, but area of the square is s squared. So that is going to give me 16 squared. Area of the square is 256. Area of a circle is pi r squared. That's pi times the radius, which is 8 squared. Going to give me 64 pi. And even though they're in fourths, I don't need to divide that or anything because it made a whole circle. And then in the end, all I got to do is subtract them. So my final area is square, which is 256, minus circle, which is 64 pi. I can't actually combine them. Parentheses, centimeters squared. Okay. We good? Alrighty. So then, this one here says TW, ray TW, angle VTUs, which means this and this are congruent. Arc TV, which they've already labeled, is 104 degrees. I want the measure of angle UTW. So this is the one I'm actually finding the measure of, but these two here are congruent. So if they got bisected, the angle measures are the same. They both have the vertex on the circle, which means that they are both half of their intercepted arc. So their intercepted arcs have to be congruent. Whatever these arcs have to be congruent. Well, I can easily find that because I know the rest of the circle. If I just take 360 and subtract 104, that's going to give me 256, right? That's all of the rest of this. And then I'm just going to take that 256 and divide it by 2 to get each arc. Oops. So half of 256 would be 128. Right? So this is 128, and this is 128. So here to find this angle, this is one of those where the angle is equal to half of the arc. And you substitute in what you need. You need the angle, it's half of 128. So the measure of angle UTW is equal to 64 degrees. There's another way I could have done it. Could have looked at this as, all right, well, this is 104. So this angle right here is half of that. That would make this 52. Okay. And then I know that if I called this x and this x, that x plus 52 would have to equal 180. So 2x plus 52 equals 180. So 2x equals 128, and x equals 64. You get the same answer either way, whether you use the angles of the arcs. It doesn't matter. Okay, you think of that? That's good. All right, then measure of angle AED. AED is 95, it's already labeled. Measure of arc AD is 120. What's the measure of angle BAC? Okay, so on this angle, well, this angle right here intercepts this arc. Okay, so in order for me to find this angle, I need that arc. Well, that arc is also intercepted by this angle here, which is not a central angle. Like if this is 95, this is 95, but that arc is not 95 because that vertex isn't at the center. This is one where it's got these two intercepted arcs. And if the vertex is inside the circle, then the measure of the angle is equal to half of arc 1 plus arc 2. So we'll just call this x, so we have something to call it. I know the angle, it's 95. It's equal to half of this arc, which is x, plus this arc, which is 120. I could distribute the 1/2. I'd rather multiply both sides by 2. So when I multiply both sides by 2, I get 190 is equal to x plus 120. So x is equal to 70. But that's not my answer because I'm looking for this angle. This angle has the vertex on the circle, which means for that one, the angle is equal to half of the arc. I know the arc is 70, so 1/2 of 70, and I get that the measure of angle BAC is 35 degrees. There you go.